Hi everybody, I hope you all are doing great. So this is the second video of this playlist and I hope that you have watched the Fibonacci series question, right? So let us read the problem statement quickly. You are given a staircase. You are climbing a staircase. It takes n steps to reach the top. Okay. Each time you can either climb one or two steps, right? I can either take a one step or I can take two steps in a staircase, right? In how many distinct ways can you climb to the top, right? Okay, problem seems very short and let us now try to comprehend this problem on the board itself. So let's say n is equal to 3 for instance. Let's take n is equal to 3 and let us try to analyze that in how many distinct ways can I reach the third stair. In how many ways I can reach the third stair. So 0 I can and you already know the question that I can either take a step of 1 or I can take a step of 2, right? Or I mean either I can from this zero stair I can either take a step of 1 and come on 2, or I can take a step of 2 and I can directly come on 2, right? Basically skipping 2 stairs. Let's read the question again. So each time you can either climb one or two steps, right? So this is a step of a stair. I can either climb one step from 0th or I can climb two steps and I directly reach 2. So let us analyze. I want to reach the third stair. Let's say from the 0th stair I'll take one step. From the 1st stair also I'll take one step. From the 2th stair also I'll take one step. So I'll be reaching 3. So let's say this is a way I have reached the third stair taking one steps, right? From every stair which is there. Let us elaborate more. Let's try to find some other way. I'll take a step of 1 on the 0th stair, and from the 1st stair this time I will take a step of 2. Can you see? I'll easily be able to reach 3 by this way, taking a step of 1 and then taking a step of 2. Exactly. Okay, let's discuss any other approach. From 0 this time I'll not take step of 1, I'll take a step of 2. I take a step of 2 and suddenly I'm on the third stair, on second stair, and then from here I'll take the step of 1, I'll reach the third stair. So 2 1 is also a way. Let us verify this if we are correct or not. So you can see when n is equal to 3, you know answer is coming out to be 3, and yes, there are three ways. You take one step and one step, you take one step, two step, and you take two step, one step. Definitely these are the ways we have calculated. I hope the problem is clear to you. There are three ways to reach the third stair. If at every stair you are having a choice of taking one step or two steps, correct? All right, this seems fine, and let us now analyze a case of n is equal to 5, right? Let us analyze n is equal to 5. So I'll just erase these things. Just put n is equal to 5 here. So let's say n is equal to 5, and let us try to calculate in how many ways you can reach the fifth stair. ठीक है जी. Now talking about the fifth stair, there can be multiple ways to reach the fifth stair. To reach the third stair, there are three ways to reach the third stair. Correct? You know, and let us quickly analyze, right? So if I want to reach the fifth stair, from which stair I can reach to the fifth stair? I can either reach the fifth stair from the fourth stair, taking a one step, taking a step of 1, or I can also reach the fifth stair from the third stair, taking a step of 2 from here. Correct? Correct. Now, can you observe something? The number of ways to reach the fifth stair will be what? It will be the number of ways you can reach the third stair, and from those ways you will take a jump of 2, plus the number of ways you can reach the fourth stair, and out of all those ways I'll take a step of 1. Let us quickly calculate. ध्यान से देखना. So to reach 1, how many ways are there? I can only reach 1 by single way. I'll take a step of 1 here and I'll reach 1. Okay. So to reach 1, there is only one way, and that way is taking a step of 1. Correct. I'll write the ways here, right? To reach 2, how many ways are there? From 0, 1, 2, right? From 1, if I go to 2, right? So number of ways I can reach 1 is 1. After all these ways, if I reach 2, it will be 1 plus a 1. So 1, this one to reach this stair, and this one to reach 2. And another method is if I, take a step of 2 from 0 itself, I'll be at 2 itself, and suddenly I'll be the step will be 2. So these are the two ways to reach 2. Correct. Let us look at the ways to reach 3. Now you will be able to understand, and 4 and 5 onwards, so it will be clear that what the problem is actually saying, and many of you recursion is will also be clear. ध्यान से देखना 3 में देखना, to reach the third stair, let us see in how many ways I can reach the second stair, because from the second stair I can directly reach to the third stair. So I can reach second stair from these two methods. Here I will write these two methods here, and in front of these two methods to reach the second stair, if I write 1 1, will I reach the third stair? Definitely I will. Definitely I will. Right, because from the second stair, third stair is only one step away. From which other stair can we directly reach the third stair? From stair 1. So how many ways are there to reach the stair 1? It is only one way, which is 1. And in front of this, these ways, which 1 has written here, if I add a 2, because from 1 to reach 3, I'll be taking a jump of 2. This will be the way to reach 3. Are there any more ways to reach 3? No. Right. So can you observe something? 3 is taking help from 2 and 1. Right. Because 2 and 1 are the people from which I can reach 3 directly. Alright. Let us analyze a little more. Let's talk about 4. If I want to reach the fourth stair, I can take a jump from the third stair of step 1 and I'll be on the fourth stair. So these are all the ways to reach the fourth stair. 1 1 1 2 1, to reach the third stair 1 2. And in front of all these ways, if I take a jump of 1, from this way also I'll take a jump of 1, from this way also I'll take a jump of 1, from this way also I'll take a jump of 1. Can you see these are all the ways to reach the fourth stair? Yes, definitely. Look at this 2 now, because if I want to reach 4, I can also take a jump of 2 from 2, right? So all the ways to reach 2 are 1 1 and 2. In front of both of these things, if I add a 2, can you see these are the ways from which I'll also be able to reach 4? Correct. How many ways are there to reach 5? Can I say the number of ways I can reach 3 plus the number of ways I can reach 4? Correct. Because what is happening? The number of ways I can reach 4, I will add a 1 in front of them, and all these things will be copied. Plus all these ways to reach the third stair, I'll add 2 in front of them, and these, the sum of both these counts, right? So there are 3 ways to reach the third stair. You can see there are 5 ways to reach the fifth stair. To reach the fifth stair, like there'll be 8 ways, right? So all the ways to reach 4 plus all the ways to 3, right? Let us verify, if it comes an answer. I'll just give a dummy, input here. So, this is how you analyze a problem, right? Let me, add a test case. Let me rename this test case and let's add a 5 here. Let's see what's the output, right? This is how you have to solve the problems as well. Just give a dummy input and, expected output is 8. Okay. So this means our thinking is correct and we are actually on the right path of the test cases. We have successfully generated our own test case. We have successfully got the answer for the own test case using the approach itself, right? Now let us try to derive a recursive relationship out of this. Now let us look at the recursion and how can we derive the recursive relationships. Can you observe one thing from this explanation, that the answer for 5 depends on how many ways I can reach 4 and how many ways I can reach 3. I'll sum both these values and I will simply give this as answer. Pretty similar to what we did in Fibonacci numbers, right? So ध्यान से देखना what is the recursive relationship. If I want to get the answer for 5, this answer is dependent on what? This answer is dependent on how many ways I can reach 4, and this answer is dependent on how many ways I can reach 3, right? Because from 4, if I know that how many ways I can reach 4, I can simply take a step of 1 and I'll be on 5. And from this 3 as well, I can simply take a step of 2 and I'll be reaching 5. So how many ways to reach 4? How many ways to reach 3? I'll ask for the other recursive calls. I'll have the faith that they will do their work correctly. Let's look at this. F of 4. Now f of 4 will be calling two things. It is dependent on f of 3 and f of 2, right? Because these are the only two stairs from which I can directly go to the fourth stair. F of 3 is further dependent on f of 1, f of 2 and f of 1, right? Let me take this tree a little bit right to the right side. I hope that I'm not blocking the view. So this 2, you can see it is dependent on f of 1 and f of 0. correct? This f of 1, can we now calculate the answer? Because we already know to reach 1 there is only one way. Just take a step of 1. So I'll return 1 from here. That there is a single way to reach 1, that I'll take a step of 1. How many ways can I reach 0? There is a single way, that I don't do anything, right? From 0 also, na, there'll be a way to reach 2. So this 0 will also be returning a 1 here, correct? Saying that if I want to reach 0, I'll not do anything. F of 1 will say that if I want to reach 1, I'll take a step of 1. Good. F of 2 we are having. Now f of 2. It is how many ways I can reach f of 1? It is a one way. How many ways I can reach f of 0? It is a one way, that I don't do anything. And from this step, I will take a step of 2 and I'll reach f of 2. So what will be the answer for f of 2? It will be summation of both these values. This will be returning 2 here. F of 1. We already know the answer. It is 1 because this is a base case. 1 and 0 are base cases. So I'll return 1 from here as well. F of 3. F of 3 is dependent on in how many ways I can reach 2. I'll take a step of 1 here. And in how many ways I can reach 1? I'll take a step of 2 here. So 3 will be returning 3 here, correct? F of 2 will further do the recursive calls. Now you can of course see why dynamic programming is getting applied here, because f of 2 we are again trying to calculate the answer, right? So f of 2 will call f of 1 and f of 0. And from here I will return 1. Here also I will return a 1. F of 2 will suddenly return what? It will return 1 plus 1, which is 2, right? Saying that there are two ways to reach 2. Now f of 4. Has f3 done its job correctly? It is returning 3. Yes, there are 3 ways to reach 3. Has f2 done its job correctly? Yes, there are 2 ways to reach 2. Both of them has done their task successfully and faithfully. Now, I have to do my expected work, which is I have to return how many ways I can reach 4. It is number of ways to reach 3 plus number of ways to reach 2, which is 3 plus 2, which is 5. Are there 5 ways to reach 4? Definitely there are. F of 3. Now you can see again a repeated sub problem, right? We'll be drawing the same tree again here, right? So f of 3 is dependent on f2, f of 3 is dependent on f1, f of 2 is dependent on f1 and f0, right? From f1 I'll be returning a 1, from f0 I'll be returning a 1 itself. From f of 2 I'll be returning 1 plus 1, which is 2. From f of 1, what will I return? I'll return 1 because this is the base case. F of 3, from what do I have to return from here? 2 plus 1, which is 3. I'll return a 3 from here, correct? So can you observe this, that we have successfully calculated the number of ways I can reach 3 again, right? That is the important part in dynamic programming. So now f of 5 can do its job correctly. F of 5 will simply return itself, and it will simply return 5 plus 3, which is 8. And we have successfully completed the recursive call for this. Let me write a little bit of pseudocode here so that it is clear to everybody. So I will write here that we are having integer function. I'll write this function name as recur, and an n will be passed to us. If n is 0 or n is equal to 1, this is the base case. I'll return what? 1. And what about the next things? If n is not 0 or if n is not 1, it will be calling its previous stair and previous stair. So integer n minus 1th stair is recur. Number of ways to reach the n minus 1 stair is recur of n minus 1. Integer n minus 2th stair is equal to recur for number of ways I can reach the n minus 2 stair. What is my answer? Return. ध्यान से देखना, I'll calculate in an integer. Integer answer is equal to what? N minus 1 plus n minus 2, and I'll return this answer from here, and this will be the whole recursion code itself, right? So we have successfully seen the recursion thing, and let us go and code this out quickly so that we can go move forward to memoization. So we are back on the coding editor, and let us write the recursion function we wrote in the board. So recur, it's C++, sorry, I have to change it to Java. So let's reset the code. So public int recur. I'll write an integer n here. And for this n, if this n becomes 0 or this n becomes equal to 1, I will return 1 because this is the base case. Now comes the real part. If I want to reach the nth stair, I have to get how many ways, in how many ways I can reach the n minus 1th stair, which is recur of n minus 1. Oh, I have to write minus sign here. And how many ways I can reach the n minus 2th stair, because from that stair, if I take a step of 2, I'll be reaching the nth stair, recur of n minus 2th stair. In the end, I'll be calculating the answer, which is n minus 1 plus n minus 2. And from here, I will simply do what? I will simply return the answer itself. And this is the recursive code for this problem, return n. The solution is getting accepted. And this is the recursive solution. Right. In the last video, we saw what is memoization and how to convert recursion from memoization. Let us look at that again quickly. So what I'm going to do, answer dekhna yaar. Again, let us call the recursion quotient because memoization is actually recursion only. So f of n, and now from f of n, like let's take n is equal to 5. So n is equal to 5. Let me do it a little bit quickly. N is equal to 5. Its answer is dependent on, initially everybody is having a 0 here. Everybody is having a 0. 0 denotes that the thing is not being visited. We have not calculated the answer yet for that ith index. On the memoization array, on the second index, we'll be storing how many ways, in how many ways I can reach the second stair. On the fourth index, I'll be storing in how many ways I can reach the fourth stair. So f of 5, we have to calculate the answer for f of 5. So I will call for f of 4 comma f of 3. F of 4 will further call for f of 3 and f of 2. F of 3 will further call for f of 2 and f of 1. F of 2 will further call for what? F of 1 and f of 0. Now, we already know the answer to these base cases. So here we directly return 1 and 1. You know, these will do their task in constant time, right? I can say that, right? If I'm calling f of 1, it will not be calling someone else. It'll do its task correctly. So we actually don't need these indexes for the base cases because we already know the answer for them. F of 2, on the other hand, wants to calculate its own answer and it will be the sum of whatever value is here. Before returning the summation of 1 plus 1, it will first store this here. I will first store 1 plus 1, 2 here, and then I will return the answer here itself, so that in the future, if we call 2 again, we will not be again calling that function again. So if you look at this closely, f of 1, we already know the answer. So f of 1 will be returned from here. F of 3, can I say something that f of 3 is about to be calculated, and before returning the result, I will store the result here for future references. So 3 will be stored here and we'll be returning 3 from here. Now f of 4 is calling f of 2 again. My friend, can you see this, that we have already calculated the answer for f of 2. I'll do not call further. I'll just simply check if this is a base case. This is not a base case. I will simply check if this is something I already have. Yes, this is something I already have. So I'll return this 2 itself. And f of 4 will do what? It will return the sum of these. But before returning, I will remember the answer. I will remember the answer. So I will return here. I'll have a 5 here. Now it's time to return, and 5 is calling for f of 3 now. Can you see at the third index I'm not having a 0. If I'm not having a 0, this means that I've already calculated the answer. I will check whether if this is a base case. No, this is not a base case. Is this a person I already have an answer for? Yes, because there is no 0 there. I will return whatever value is here. I will blindly return 3 because we have already calculated here. I have already made further calls for this. So I will just simply return 5 plus 3, which is 8. But before, of course, returning, I will store the answer for 5 as well. And this will return 8 to me itself, right? So this is memoization, and this is how we are going to solve. In memoization, if I write the steps, first you check the base case. Second thing you check is, do you have that value in your DP array? Do I have it already? And then, your recursion code comes in, and, then you calculate the answer recursively. But before returning the result, remember it, remember it, and then return. right? I hope this is clear to everybody. And these are the steps basically in memoization. Let us quickly code this out and then move to tabulation. So let us quickly code out the memoization code. What did we do in memoization code? First of all, I'll take an array of length 5. Whatever n is there, I'll take an array of length n plus 1 because I want the nth index as well. So integer array dp is equal to new integer n. And by default, at every index, there will be 0 present here. Correct. So let me comment this and let me write the memoization function. How do we write memoization? Just copy recursion code. Just copy this recursive code. Just change the recursion wherever you have written recursion to memo, whatever function you want to write. I've renamed it to memo. This will accept a parameter called dp itself, right? And after checking the base case, I will check if dp of nth person is not equal to 0. If dp of n is not equal to 0, I will return what? I will return dp of n. Again, if dp of n is not equal to 0, this means that I have already solved the answer for that person and I can simply return whatever value is on this index itself, right? But here, before returning also, what do? dp of n is equal to answer and then we return. So we remember the answer and then return. Remember before return, and this is what? Check if I already have the answer, right? So this is the memoization code. I think, yeah, from here also, like, you have to write dp because we are adding a parameter here, and I think now it looks perfect. So I'll call this memo function return memo of n comma dp, and let us see if this works or not. Let us run this code. Okay, so runtime exception, index out of bounds. So it is n plus 1, sorry. Length I have to create of n plus 1 because of 1 based indexing, right? Because if I'm taking length of n, which is 5, the last index will be of index 4, right? That's why I have to take an index of n plus 1 here to accommodate the 1 based indexing, right? So now it would work just fine. Let's submit this quickly and then move to the tabulation itself. So it is getting submitted. Let us move to tabulation itself. So tabulation, as we saw in the last video, is a bottom-up approach. So we'll be building answer from the base case all the way to nth person. So we already know the answer for the base cases. Answer for 2 will be 1 plus 1, which is 2. Answer for 3 will be my previous index and the previous to previous index, the sum of that, which is 3. Answer to 4 will be 3, my previous index, plus the sum of the previous to previous index, which is 5. Answer to 5 will be my previous index plus previous to previous index, which is 3, so it will be 8, right? So you can easily get the tabulation correct for this problem. Although I'll directly discuss the trick with you, which we discussed in the last class, and we'll be solving through the trick itself, right? So let us go to the code itself and let us list the steps to accommodate that trick to convert memoization to tabulation in few steps. These were the steps we discussed in the last video to convert memoization to tabulation. We have already done the step 0. We have already coded the memoization solution for this. Let us look at the tabulation. How do we convert into tabulation itself? So here we are going to have first create a function called public int tabulation. And I'll pass this dp here itself because we have to create the dp, and integer n I'll pass here, and integer array dp I'll pass here. Of course, dp will be the length of whatever memoization you are taking. So memoization, whatever length is memoization, that will be also in the tabulation itself. So we have got the dp array set, and now we have to start the loop from the base case. Look at this. We have to start the loop from the base case. What was the base case? It was 0. So 0 was the lowest base case. So I'll be starting a loop from I is equal to 0, I less than equal to n, I less than equal to n, and I plus plus. Right. Now here, the next thing I want to do, I have to copy paste this whole code. Let's copy paste this whole code inside this loop itself. And after copy pasting, wherever I have written I, actually this is now representing n. So wherever I've written n, that is I. So I'll remove all these n's from here. So of course only n's. So wherever I've written n, that is actually I this time, right? So I think these are all the n's. I've replaced them with I. Okay, because n is now bounding the loop. It is not the person, the stair we are talking about. We are going to solve for the ith stair. So n is converted to I. So okay, so what's the next step? Converting return to continue. Okay, we have to convert all the return statements to continue statements. If the return statement is having a value same as DP array, save that to DP array and then continue. Okay, so where can we see here? We can see a return value, and this is we are returning something here. So what will I do here? DP of I is equal to 1 and then continue. I have saved that and then I've continued. Where else can I see this return? This is the memoization part. So memoization part we can simply delete, right? We can simply delete that part. Here also I can see a return. So before returning, I'll do what? I'll do DP of I is equal to answer and then I will return. Actually, we are already doing this. So I'll just delete this line of code. Okay. So all the return statements have been converted to continue. I'm not writing a continue here because, of course, after the loop has ended, continue will automatically happen. So the step 2 is done. The next step is at the place of recursive calls, access the DP array. You can see here at the place, these are the recursive calls I'm making, right, to memo, right? So I'll try to access the DP array instead of these recursive calls. Here as parameter, can you see I'm passing I minus 1. I'm passing a I minus 1 here. So I will try to access the DP of I minus 1th index here. Here can you see I'm passing as a parameter I minus 2. So DP of I minus 2 I will try to access here. Instead of calling the memoization function, I'll simply access the DP array and that parameter, whatever parameter I'm asking, right? So I think this is it for the tabulation. I'll simply return what? DP of n as the answer, because this is a bottom up approach. We are starting from the base case all the way to n, and hence we have returned DP of n from here. Let us call this function return tabulation. I'll pass n comma DP here. I think the spelling for tabulation might be wrong. Tabulation. Okay. So let us try to run this code. I have to, of course, remove this. So let's try to run this code. Let's see if it runs. So it is accepting. Let's try to submit this, and yeah, it is getting accepted too, right? So definitely tabulation is also done for this problem. Memoization is also done. Recursion also done. We can also optimize space in this problem. So let us see how can we optimize space quickly. Now in space optimization, we can definitely see that we are dependent only on the previous variables, right? Previous two variables. So just like in the Fibonacci numbers we did, we'll be solving this as well. Let us directly code it itself. So public int, what do we call it? We call it space optimization of t. I'll pass integer array n here itself, right? So in the last video, we saw using a variable called n minus 1. I'll be storing 1, and integer n minus 2, I'll be storing 1 in here itself, right? Also, you can observe here, right, that, if n is less than equal to 1, I'll be returning 1 itself. So we are ready to calculate the answer for next n values. So ध्यान से देखना यार, for integer I is equal to 2, I less than equal to n. Why am I starting I from 2? Because for I is equal to 1, this is the answer. I is equal to 0, this is the answer. I is equal to 1, this is the answer. This is the answer for I is equal to 2. Integer current answer will be what? It will be n plus 1, n minus 1 plus n minus 2. If I is equal to n, I will simply return current from here. And else I will do what? I will move forward. How do I move forward? N minus 2 becomes n minus 1, and n minus 1 becomes current, right? And here I'll do a dummy return. I'll simply, dummy return. So we'll never reach this return statement because we'll always return from this return function itself. This is the space optimized solution for this problem. I'm not going over the, how we have achieved this solution, because we've already covered this in the last video itself. So if you are following correctly, you'll of course remember the syntax, that n minus 1, n minus 2, and then simply current we are calculating, and then we are moving forward with the, if n I is n, so we have calculated the answer for nth stair. Else we'll move forward, and this will become its next stair, and this n minus 1 become the current stair, and in the next iteration we'll be calculating the current share itself. So I'll pass here n itself, and let us see if this solution runs or not. Okay. So let us submit this here itself. So it is getting accepted, and yes, let me remove this space itself, and let's see now if this is happening. So this solution is getting accepted, and these are the 4 ways to solve this problem. using recursion, memoization, tabulation, and space optimization, right? So I hope you enjoyed this lecture. I hope you are somewhat getting a hang of the trick we are using whenever we are trying to convert recursion to memoization and memoization to tabulation, right? So hope to see you all in the next video. I hope you are enjoying the videos. Please support the channel if you are doing so, and until the next video drops, bye.